Check, 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 check. All right, so public service announcement. If you are eating your chicken biscuit without maple syrup, you are doing it the wrong way. I can assure you. If you have not tried it, you've not had a chicken biscuit. So there is maple syrup over here. Please indulge. Please sate that appetite for all the sugars. Additionally, we also have peach cobbler. So get in on that today. A little special treat from our man Chester over at Cancun. So today, as Lee here is giving the talk, if you want to ask a question, try to grab this mic here. It'll be right over there. So grab that and then ask your question. If you really need to shout it out, burning question, and you don't have time to get the mic, just shout it out, and then Lee will repeat it for our live stream, because that's what this is all about. If you don't have the mic, the live stream can't hear you, and then they don't know what in the hell Lee is actually talking about. All right, we're going to let these few last folks roll in here, and we'll get started here in just a few minutes. That's right, Patrick. Patrick knows what's up. Everybody look at Patrick. Patrick is taking the maple syrup, and he is applying said maple syrup to his biscuit and showing the world how to eat chicken biscuits. Am I in focus, Kyle? Want to make sure I'm beautiful for all the viewers. There is one. Oh, there is a Coke under there. Right here. Amateur hour over here on my part. All right, ladies and gentlemen, welcome to Chadev. Today we've got Lee, who came all the way down from the Tri-Cities area. Nice little drive down this morning, I'm told. So give a warm welcome to Lee. He's going to be talking about Terraform today. Come on up, Lee.
Am I on? I don't hear myself. There we go. Well, thanks for letting me come down. I'll get the first slide brought up here. So as we get started, let's see. Technology never works. Let's see if I get this going. I've never tried using my phone as a remote, so bear with me. But I want to tell you guys about Terraform. It's managing your infrastructure as code, so we'll talk about some cloud infrastructure today. I'm curious, we were chatting over here already. Anybody here already know what Terraform is? Excellent. Anybody use Terraform day to day? Awesome. You guys will not know when I'm telling lies. This is perfect. I'm going to briefly hit my background so that you guys know like what I've been doing and how I got here. I've been programming for about 16 years. I hated C++ and went to Python. Absolutely fell in love with Python, and up until this job right now, I'm doing some Go right now, but it's still a lot of Python, so that's always the first thing I reach for. I was at the Washington Post and National Geographic back around 2009 through 2011 and worked on not really their main content management system, but a video content management system. And as part of that, learned a lot about infrastructure, learned a lot about these enterprise class storage systems and all this cool stuff. And I was like, okay, I had learned about render farms in college. So my degree's in computer animation, I'm a glorified artist. So I made the jump over to programming, and I loved the concept of a render farm. It was MapReduce before people called it MapReduce. And so it works really cool. And Terraform, obviously the way I'm using it today, like every day I'm thinking, gosh, I wonder if guys at Pixar, I wonder if these guys are using this. So I know some guys at ILM, you know, they've written a lot of their own tools in Python, and Pixar recently, well, I shouldn't say recently, I'm out of the loop now, but about 3 years ago, Pixar was using Python to do their new RenderMan manager. So that's, and boy, that's great. You get a phone call on your remote. So that's kind of my history. I've been all over the place, bouncing back and forth, and this seems to be a really good marriage. So I'm doing DevOps at a company called ŷhat, and we build data science tools. We have a product actually right now. It's open source. If you guys want to check it out, download it. It's called Rodeo. It's an interactive IDE. And we also have a software suite that runs hosted in the cloud or on premise. So we'll dive right in. I'll give you all, that's all the background. I'll jump right into Terraform here. I'm an expert, and you should trust me and believe everything that I say. I've been using Terraform for 5 years. I'm kidding. Terraform's been around for about 2 years now, maybe 18 months to 2 years. I'm just a big fan. I'm a fanboy of Terraform. So this presentation, to kind of set the tone, interrupt me, ask questions. If somebody's using it and you're like, oh, you should totally do this, like call me out on it. Because we don't have time to dive into everything I would love to show you all, because Terraform covers a lot of ground today. And I thought it was best that we just focus on what I like about it. And so if you're taking notes, write this one down. Terraform's pretty cool, and you can attribute that to me. What we're going to attempt to do is we'll define kind of loosely what Terraform is. I've got a couple quick code samples, really small, lightweight samples that we can read on a slide and look at and compare and contrast with CloudFormation. So who here uses AWS? All right, good, about half the room. DigitalOcean? All right, Rackspace? Rackspace guys, you guys using Heat? Have you touched that at all? That's the Rackspace OpenStack kind of equivalent to CloudFormation. So my big thing right now, it's automate everything. So I've got some code samples that will demo how this automation works. My samples work every time, 60% of the time. Hopefully there's some Anchorman fans in here. I'll highlight briefly what I do at ŷhat. And so I manage all of our automation for builds and deployment and setting up new customers when they're choosing us to be hosted. And so we use Terraform and Ansible and BuildBot. And because of Terraform, we have the ability to very easily go support AWS, DigitalOcean, Google Compute Engine. We could do Rackspace. We don't today. We're our main core infrastructure is in AWS. So S3 is the big glue piece for everything for us. And so back to what I already touched on, we talk about what is Terraform. They have a really great summary on their website. Terraform provides a common configuration to launch infrastructure, including physical and virtual servers, email and DNS providers, and very recently they added database internals. So they actually have the terminology in Terraform is a provider. And so there's an AWS provider, a DigitalOcean provider. They now have a MySQL provider and a Postgres provider. which is pretty cool. Almost all the AWS services are supported. You'll see there's little features that are missing. So if you know a lot about S3 and you do S3 versioning in your buckets, they do not currently have a way to express versioning life cycles, which is a bummer. But that's on the roadmap, it's coming. One of the things that really impressed me, I had built some infrastructure as code within Ansible itself about a year ago and found out that the RDS API had moved far beyond what Ansible provided support for. So if you wanted an RDS instance, and if people don't know, sorry, if you don't know what RDS is, in Amazon Relational Database Service, so it's your hosted Postgres, is what we were using it for. And what we found was we couldn't specify at launch time through this code that we wanted our database to have an encrypted file system. So it was like, well, what are we doing now? That's a waste. We can't launch our infrastructure. So I started looking around. That's how we landed at Terraform. And Terraform is built by the guys who make Vagrant, so I'm sure quite a lot of people have at least heard of Vagrant at this point. It's written in Go, and the configuration files that we're going to look at are in their own language. It's HCL. You can choose to write these in JSON. So if you have a Python tool, I've written some Python tools that do this. If you have a Python tool that does something on top of Terraform to kind of lay the groundwork for what Terraform's going to do, it can render out JSON, and then Terraform can read the JSON. But when I'm manually writing out infrastructure, then I choose to go with HCL. And so this is a really simple example. This gives us an S3 bucket. And I was talking a minute ago, we talked about the kind of the lingo that Terraform uses. Because S3 buckets live in AWS, we have this concept of a provider. And in this case, the provider is AWS. And these are defined within Terraform itself. And all we're doing here, your access keys, your secret key, those all live in environment variables. So you could put them in here. I would obviously recommend that you don't. But we do specify the region. So this is really handy. I'll show you some code later, but when we isolate environments, at ŷhat, we run our sandboxes in a completely separate region than our production. And that's part of me. I'm super pedantic when it comes to managing infrastructure. I want, especially with automation tools, I want zero chance that we're going to blow up a production system. So sandboxes live other side of the country. And so that's really useful. In our configuration files themselves, we can say, this stuff lives in US West 2. And the second thing you'll see there, that's a resource. Now resources, the first string that you define, that's something that you would read in the Terraform documentation. So if you want to make an AWS S3 bucket, you go look in the documentation and they would tell you, okay, use the resource keyword, and then in quotes, you're going to call AWS S3 bucket. And then the next set of quotes, we make that up. So that's our internal Terraform variable name. So we're calling this my-cool-bucket. You can use dashes, you can use underscores. We'll use underscores later, but in this case, I wanted it to match the name of the bucket. So that's what you see happening on the next two lines. That's what's actually describing this bucket. So bucket is the name of it, and so my cool bucket. And then ACL, we go ahead and set it to public read. So S3 defaults to owner only. So that's really important. So if you take any of this away and you're like, you see this stuff today and think this looks cool, documentation has all this information in there. They have tons of examples. It's a great website. If anybody else here, I don't know if anybody's used CloudFormation, if you've went down that path. CloudFormation's pretty cool. You're locked in, as far as I know, into AWS. There may be some tools that translate those JSON files back and forth, but CloudFormation is all JSON, and this is basically the one-to-one of what this Terraform code's doing. So we would say, I have this resources mapping, and my cool bucket is an AWS S3 bucket. But there's some things that I'm not crazy about, and this was a very limited experience. So again, if somebody's used CloudFormation and you love it, grab me after this and tell me about it. But we got to name the bucket what we wanted, and we got to make our own variable, and we'll see because we're going to be able to reference these variables as we build our infrastructure. With CloudFormation, they generate the names for you. So for the variables and the back references. So I don't know. I wasn't a big fan of that. So I've got a really simple example set up. It's basically what we just looked at, so where we can actually terraform a bucket. So we're going to have a working directory. We're going to make a file just by my personal convention. I call it main.tf. All Terraform files, that's what Terraform reads. It reads files that end in .tf. And again, those are HCL in this case. And so I've got some comments in here, which is another big advantage for me, using that over JSON, since JSON doesn't properly support or doesn't officially support comments. So we configure AWS with the default region, and we create a demo S3 bucket. So I have to be very careful. Can everybody read that? Some files going here. So I have my main.tf already in here. Let's make sure that lines up, and it does. I need to make sure that I'm activating my account, and ŷhat doesn't fit the bill for this demo. So we'll activate my AWS account, and the first thing you do when you have Terraform files, and I have, the command is Terraform, and I alias that to TF just because I'm typing it all day. So when you see me type TF, that's an alias, but it would be Terraform. And the first thing you do is you run TF plan. And we'll talk about this, I've got slides to back this up, but the TF plan, what it's doing, you have a state file that exists on your disk. And it's a JSON, big JSON file, and it's what your infrastructure should look like. So at this moment in time, we have an empty JSON file. And so it's analyzed that file, and then it's called out to the S3 APIs, and it said, okay, I'm looking for this bucket that's called chadev-tf-demo, and we can see this down here on the bucket definition. And that's separate from, again, what I called it. I used underscores for my variables within Terraform. And so what the plan will tell you, the plan goes out and it compares the infrastructure and says, okay, this is what I'm going to do for you. So at the bottom, we have a summary. The plan is there's 1 to add, 0 to change, and 0 to destroy. So that's always important to read that summary. And so to actually get this out into production, we run Terraform apply. Now, AWS, I ran this last night to make sure it works. So great, it went. Sometimes S3 bucket names will not, you can't use the same bucket name right after you destroy it. So that was a bug I was running into last night, so glad that worked. We'll switch back over. Let's get this going again. So what we just went through, we defined our infrastructure in our main.tf file. When we were in that directory when we ran Terraform. So we got the Terraform plan, and it told us, hey, there's one thing that we're going to add. We ran apply, and it tells us the apply was complete, 1 resource added, 0 changed, and that all looks great. And so I mentioned this state file. That may be kind of hard to read. I don't know. That's not too bad. But we can also bring it up in the terminal. That's going to live right now next to your infrastructure. So if we pull up terraform.tf state, there's this JSON that describes everything that our HCL. So right now we're 1-to-1. Our configuration and the state match. So if we run Terraform plan again, it should, if everything works, tell us that, hey, there's no other changes to make. So we're good there. So I'll hit the highlights again. It's JSON. It updates when Terraform runs. They promise to keep it backwards compatible. I will warn you, because Terraform moves really fast, they may add support for a module, or they may tweak one thing in a module. And so while it won't break your state file and it'll work fine, what you can run into is if I'm using a newer client and I generate my state file and apply these infrastructure changes using some new property, and then someone else comes in with an older client, it won't break, but it will think that that infrastructure needs to change. So you have the potential to destroy some infrastructure or revert changes. So if you're working on a team, everybody needs to stay on the same version. They have a hosted product called Atlas that kind of solves that problem. It centralizes where these plans run. So anyways, small tangent. We were just talking about state, so I wanted to throw this out now. Right now, it's on your disk. Lots of sensitive information will end up there if you use Terraform to its fullest potential. So you can create IAM users with this. And their access credentials, if you create access credentials for these users, you'll see their private key, their secret key, and their access key ID. It'll be in this state file. So if you commit this state file to GitHub, if everybody follows the security stuff, you've committed the same treason as everyone that hard codes AWS credentials in there and puts it in GitHub. So the way around that is you configure remote state. Now their service called Atlas, they can do remote state for you through that. They also just have S3 as a backend for remote state. So there's this command line thing, you say Terraform state configure, and I want to do remote, and you tell it what S3 bucket to hit. So what's cool about that, though, there's an added benefit. So besides getting that state off of your disk, so if you're working with a team, everybody's going to be pushing and pulling that state. It is possible to get out of sync. It's kind of like database migrations. Having this tool doesn't replace effective communication with your team members to say, hey, I'm going to do this today, or hey, I'm going to go do that. But what's really neat is if we take our example we just did, we defined that bucket. And if we had that set up as a remote state, I can actually use that remote state over in a totally different Terraform environment configuration. And that's what I'm doing here. I can just say, hey, Terraform, here's this remote state. And in our example here, we have this remote state called core. And that's all of our core infrastructure. And it includes Route 53 records. So sometimes I'll make a sandbox, and I'll want my sandbox to be accessible through a domain name that shows up under ŷhat.com. And so instead of hard coding things over in that, I can basically do a back reference. And it'll back reference over to this remote state, and it'll figure out, okay, he's saying he wants to use this subdomain zone ID. So it'll look that up for us. So it's a really, really, really great way to keep all your infrastructure loosely coupled like that. And so let's do some real infrastructure. We're about 20 minutes in right now, so I'll try to speed up. This is what creating a server looks like. So if anybody's used a launch wizard before, you've done this stuff, you have to have some key pair. Sometimes it will create one for you. So with Terraform, we're going to get ahead of the curve. We're going to create our key pair. We're going to define it and name it. And now we can see these back references in use. We can see I'm creating this demo server, and for the key name, I'm calling back up to the AWS key pair that I'm defining right there. So this is starting to expose the pattern and the power around Terraform. Define something in one spot, reference back to it. It's almost like a real programming language. There's no control structures in here, though, so for loops and things like that aren't doable today, and they may not add it. So let's pop over here. Let's see. I tried to do all these as commits, so hopefully we can jump here. Well, let's always do a plan first. I'm about to do bad habits. When we worked as a team at my previous company, what everyone would do, they would make a pull request to GitHub, right? So here's these changes. I'm on a branch. Here's the changes to the infrastructure I want to make. We would run Terraform plan. We would copy this plan output and include that either in the commit message or, most importantly, as a comment or in the body of the pull request. So when you were reviewing an infrastructure change, you pulled down their branch, you ran Terraform plan, and you made sure that plan matched the output that was included with the pull request. And Terraform has the ability to save this output too, so you can guarantee that the output that you see is what's going to happen. I take shortcuts and don't do that, so I'm probably teaching a bad practice here, but we'll review really quick. It's going to add this server and add this key pair. And so we'll apply this change. And we got an error. So errors in Terraform show up in this big nasty red text, and oh no, Terraform does not roll back in the face of errors. So we'll jump back over to our slides. We've created our server. I got some notes in there. I'll roll back on that. So that's where I was talking about the back reference. So instead of hard coding that key name, we're referencing back to the key name. And all of the resources in, resources and providers actually, in Terraform in the documentation, they have basically inputs, the variables that we're defining, they have outputs. So there's variables that we can read from, which is what we did. And you can define your own for those. So we did our plan, we had to add, we saw this error, and it tells us that this server can only be used in a VPC. Who knows what a VPC is? Welcome to my talk on AWS networking internals and VPCs. I'm just kidding. We're going to blow past this. VPCs are a pain, though. And so I copied all this over. I'll post these slides up. But VPCs, oh my gosh. The wizard's pretty cool because it'll stand everything up for you. If you ever go to do this by hand, it's like try, fail, try, fail. So VPCs, you have to have a VPC definition, which is a network address space. VPCs are just software-defined networking at their core. And so you say, okay, here's my networking space. Here's the CIDR that all my addresses are going to live in. And sorry, let's get this going. And so then you have to have a subnet that's part of that address space that is the actual VLAN. And then you have to have an internet gateway so that your traffic can be routed. And then how are you going to route your traffic? Oh, you have to have a routing table that defines that route I mean, it gets deep really fast. So that's what we've added in our next commit. So, well, if I can type. We'll do a plan now on our add VPC. All right, so 6 to add, and if we scroll through this really quick, we can see the server's still in there, so it still wants to add the server. Now we have this internet gateway, so that's so we can talk to the internet. We have a main route table association, so that's saying, hey, for this VPC, always use this route table. We've defined a new route table, so we're saying, okay, hey, here's our route table and an actual subnet that ties all this together, and then the VPC itself. This is why I love Terraform, because I do this once. When I put this demo together, I went to my VPC module and copied everything and pasted it over. It took 30 seconds, and I had a VPC. Still have the same problem. VPC resource not specified. Specified instance type can only be used in a VPC. So let's go. I don't remember if I put both errors in this one, in the slides or not. Or maybe we weren't supposed to have that error at all. I got through about 60% of the demos, I think, so far. Actually, let's run through the slides, because we'll see. I may jog my memory here. So we went through parts of a VPC, CIDR block subnets, gateway, routing table, and then route table association. VPC itself's really self-contained. Subnet explains a little bit more. Again, you'll see those CIDR blocks floating around. Internet gateway, route table. All these slides will be up. I don't want to get distracted on all this. But our main.tf file is getting pretty big. And there's my public SSH key that I pasted in as one big string on there. So it's not great. It's not great for readability. I hate long files. I hate files that have everything clobbed together. So Terraform, this is a good takeaway from a welcome to Terraform talk. Terraform reads any files that end in .tf. So you can organize those however you want within your working directory. And so I prefix with the providers. So we're going to split these two things up. We're going to do aws.vpc.tf, have all of our VPC stuff over there. We're probably never going to have to touch that. And then we'll have our aws.demo.tf, and that's what we'll use. So that's where we're getting to our next commit. And if we do, well, that works, ls-1, so, or did it that way, there we go. Gosh, that's hard to read. So we now have aws-demo.tf, aws VPC. Let's run plan again, see what it says. But you can see all the things it's telling you, all the things. I'm going and checking the state. I'm going and checking the state. So this demo server, we still don't have. I probably typed a typo. So let's try to apply it again. Looking for success. Rolling the dice. Somebody needs to open a pull request so this opens up a game of Snake while you're waiting. We'll come back. It may not work. Still here? All right, we're still here. So that was it. That error is covered. So the problem was our resource. This is where you get into oh my gosh, all the ways things tie together. So our resource is still missing a security group and a subnet ID for the actual server. And I'll push up this repo too. So every commit, right, is a step along this path. So anybody that wants to kind of look at how we arrived here and the errors, you go back and run through that. So let's grab our commits again. And we were at adding the security groups this time. So we'll skip the plan because I'm a dangerous man. We're going to go straight for the apply. A little more success this time. We're getting further along. Security group was created, so we're up to the server being created. I'll let that finish running because the slides assume it worked. So we move on, and this is what's really neat about Terraform for me. Terraform will graph your dependencies. And I'm a very visual person. And so this I use a lot. It's kind of hard to read, and I'll show you how out of hand it can get. But you just run Terraform graph, and it outputs a dot file. And so that's the directional graph for your infrastructure. And that's what this looks like. So if you have a lot of infrastructure floating around on AWS, if you have S3 buckets, if you have security groups, if you have EC2 instances, if you have containers that are out there, all of that's in different tabs. If you've ever used the console on AWS, it's a huge pain. So this kind of brings everything in under one roof, and you get a really good, concise view. And it shows you the dependencies between everything. So this is a directed acyclic graph, so if you have any cycles in your infrastructure, Terraform will complain about it. It won't let you reference something the same way. So this is super useful for debugging issues with Terraform 2 or saying, how did this end up getting there? And so what's really cool, what I think, I love about Terraform is that you can compose your infrastructure as you see fit. We love S3 buckets. We like EC2. Sometimes DigitalOcean is a lot better. Unfortunately, don't work on your slides the night before your presentation because DigitalOcean will be investigating intermittent access to the control panel. So at 2 o'clock this morning, I set my alarm and got back up just so I could get this going. So we have our DigitalOcean SSH key and droplet. So it looks really similar to the AWS configuration, which is something else I like about using Terraform because we're stepping a layer above. We can kind of have an abstraction there. Somewhere there's a quote about how many problems in computer science can be solved by just abstraction. You solve any problem with another layer of abstraction except for having too many layers of abstraction. So I have all of this in here. What's really cool, remember that nasty file? I had this huge long string. So that was actually not the way to do this at all. There's a proper way to do this. Terraform can read files. So you call out and you have it say, hey, for my public key, go read my file. And so that's the way to do that. So we'll create this. DigitalOcean, the way the provider works, I should have read the documentation before I gave a presentation on it. But I did not set this up as an environment variable. You can have inputs and you can have variables that are defined. So what this will do, what this example is explaining, is we're saying there is a variable called do token, do_token. And that's where my API token is going to live. And so for the provider, for DigitalOcean, I'm now referencing that variable I defined. So instead of hard coding my API token here, I'm saying, look for a variable called do token. If I just ran Terraform at this state right now, Terraform would prompt me and say, oh, you need to provide a value for do_token. What you can do instead, and I'll share this, you can put this in your tf_vars file. And let's jump over here. Everybody that's watching on the live stream can go launch a bunch of servers for free for the next 25 minutes. Oops, we don't want Terraform. Or we do, we want Terraform with tf_vars. And so all I'm doing is I just say, that's kind of hard to read, let's bump that up on the screen. I'm just saying do_token equals, its key equals value in these variable files. And so if I didn't have that there, it would prompt me, but because I do have it there, it'll run. So let's use the powers to time travel. And let's jump ahead. And let's look at what our plan looks like today. So I've defined some DigitalOcean infrastructure, and we can see that coming up here. I've changed some things in AWS. So, and that's where we'll pick up with our slides now, and then we'll jump back over because I don't want to run out of time and take up all your time. So what I'm doing here, I'm going back to our bucket we defined, and I'm going back and I'm adding an object. Sorry, I should get my facts straight. So we define the bucket. You can actually have Terraform, if Terraform files are living one-to-one in the same repo with some project that you're working on, you can have this read a file in right here. And so what this is doing, this is saying, hey, here's an object that I want to live in S3. And the object's index.html, and it's a very small HTML file, and we'll pull it up in just a second. What's cool about this, so we go over to the bucket and we configure the website settings. So no going into the user interface in S3, no poking around in the bucket settings. We just come right here in our infrastructure and we say, I want to make this a website hosted bucket. So we do the website, and then we just tell it the index document, which is index.html, which our S3 object that we just did is uploading. And then all of these things take tags. So you've seen those. I haven't really talked about them. The tags are really awesome because there's a lot of things that you don't realize are taggable, or in my experience, in the user interface that you can tag. So Terraform makes that easy. We always put a TF, capital TF equals yes. We stay away from ones and zeros because different applications, some will parse them to an int, some will keep them as a string. So we use the string yes, but it's really great when you start automating further down the line. You can say, am I allowed to touch this infrastructure? Did this infrastructure come from Terraform? And so everything, Terraform claims its ownership through the TF equals yes flag for us. And so right now, if we curl the endpoint, and so the endpoint is our bucket name, chadev tfdemo1.s3, amazonabs.com, it will fail. So let's try that. That's where I changed the name. All right, so we get the access denied message. So if everybody can see that, so it's the same thing that's in the slide. Access is denied. And so I'm curious, where I talk about like composing your infrastructure, this is where I feel like the power. If anyone's ever dealt with the spaghetti mess that ends up with Amazon security groups, they get really out of hand. If people go in there and just launch wizard, launch wizard, launch wizard, no one looks for a security group that already exists. If you've launched 50 servers, you're gonna have 50 security groups. They're one-to-one mapped. And then so here I am working at a coffee shop, and all of our infrastructure is locked down to my house IP, so I gotta go figure out which server I need access to, then I go find the security group, then go plug in my coffee shop IP. And so that's what we're simulating here. I didn't go with a security group example, but S3 buckets can be the same way. So the other thing you can do with Terraform is you can define large bodies of text, take for what you will, there's pros and cons to this, in the file using the here doc syntax. And so the reason we do this in the file, if we don't put this in the file, we can have this external and read this in, but this is our bucket policy. And what we're doing with the bucket policy, we're saying, okay, we're only going to allow IPs that are defined here. What's cool about this is I want to allow the server I launched in DigitalOcean to have access to this S3 bucket. So there's no hard coding IPs here. That DigitalOcean droplet reference is what will pull that IP address in for us. So again, this has to be in line in your Terraform file. So some of these files get kind of long. If they get out of hand, my personal thing is I'll just break them into their own file. But we're gonna run through this. So we time traveled. So all this has been done for us. And what we want to see, and that's the kind of drill in on that. That's what we're doing. We're saying DigitalOcean droplet, chadev demo, IPv4 address, give me access. And we'll come back to the graph there. So anytime you want to see what's in your state file, you want Terraform to parse that for you, you run show. That'll parse the state file and print it to the screen. And so what we're going to look for in here, we're going to look for a DigitalOcean. Let's see, maybe I didn't time travel. We have a DigitalOcean server. Still wants to add it. Let's run it again. Actually, I should have slowed down. We actually destroyed our bucket right there. 60%. Did I make 60%? I think I did. So we'll go back here. It worked last night. So what's really cool, this is where it drives home the graphing though. This is the key point I wanted you guys to take away. So now my infrastructure is not just in AWS anymore. Now I'm not just clicking through the AWS control panel trying to figure out what has access to what. Because I have a server in DigitalOcean, now I'm going to have to go log into DigitalOcean and see what those servers are. Well, how would I know if I'm just looking at my bucket policy, what server has access to what? That, to me, is worth a lot of money. That view of the world right there. And so we can see very clearly, if we look over for you all on the right side there, we can see that the AWS S3 bucket, as you follow the arrows down, that the DigitalOcean droplet is what actually has access there. So that's a dependency graph. So what you're seeing is that depends on that, depends on that. So that's why everything will eventually drill down to a provider. But I absolutely love this. Now, with loving this, it's important to note, caveat, this can get out of hand. Now, you can control the depth that this drills in if you structure your Terraform and your files into modules. And unfortunately, I'm pretty sure I'm pretty much at the end of my time, and I would definitely want to answer questions if you have any. But I would love, if anybody's interested, take the time to read. There's information, there's little nuggets that are hidden in the Atlas documentation that's not in the Terraform documentation. And if you follow the Terraform example for getting started, they'll show you, like I showed you, hey, make this Terraform file, and then apply it. Oh, look, magically, you have infrastructure. What they don't tell you is, when you keep doing that, 9 months later, you're going to hate your life, because you're going to have copy and pasted and had typos for all of this infrastructure that you realize, okay, I always need a server. So that's what we do at ŷhat. We run these little clusters that do basically MapReduce jobs in a way, and they do some public API access for these Python or R data models. And so we spin up a cluster. So a cluster is, we have a master and we have 2 workers. We always need that. Every time a new client comes on, we need a master and 2 workers. I want to test my latest code changes. I need a sandbox. I need a master and 2 workers. And so the answer to that is you make a module. And modules give you variables that they look like templates, but they have inputs and outputs. And like I said, I don't have time to go into all that, but what you'll find is you start using modules and you're like, okay, that's really great. But wait, okay, I have a module. How do I reference, this other module? Well, okay, everything's in this one big infrastructure bundle. So now I have a sandbox that if something were to mess up, if I were to put a typo in there, my sandbox could potentially destroy our Route 53 records. Things can happen, bad things. And what you'll find in the Atlas documentation is that they explain this concept of environments. And it's just a folder. But you make a folder for what you want your environment to be. And that maps to a state. And so for us, I kind of touched on it earlier at ŷhat, we have a folder called core. And inside there is a state file. It's configured, it's not a state file, but it's configured to do remote state to a bucket to a key called core.json. Anytime I need core assets, that's what I do. I do that very loose module coupling that way. And so when you use that pattern that they show you in the Atlas documentation, it scales out really, really well. So you have modules for reusability, and then you have completely isolated environments. You can destroy an environment without worrying about repercussions. It's really cool. So thank you all. I really appreciate the opportunity to come down. I told everybody, or a few people before I got started, I've introduced Terraform the past 2 places I've worked. Everyone's had a vested interest in understanding Terraform because I was saying, hey guys, we're going to use Terraform. So I wanted the opportunity to come talk about Terraform to people that you have no vested interest in using it, because I'm not here running DevOps for you. So I hope there was something useful, and I apologize, the demos, live tech demos, never work. But I want to check, did anybody have any questions? He wants you to use the microphone.
So I noticed one of the providers is Azure. Any experience or know anybody who's used the Azure provider?
We looked at it, or I shouldn't say we, I've looked at it, but I have not used it in practice.
Okay. So one of the things that would be cool, so maybe this is a pipe dream question, it didn't appear to be the case, but who knows, you're the expert. Is there a layer of abstraction in there so that if I'm playing in AWS and I'm playing in Azure and I just want VMs, can I have a Terraform file that just says I want a VM and there's just 1 or 2 variables I can change and poof, I get it here or I get it over here?
Okay, no, not easily. And I have a similar problem. Our sandboxes, there's little things that are different about our sandboxes. So I've actually got a tool, I jokingly call it to myself every day. I'm like, okay, time to go program the mothership. Since it's Terraform, I have my mothership. But I actually just have a Python wrapper. So I define some Jinja 2 templates. You can do it in Go, you can do it in Ruby, do it in whatever. So I have some templates that are Jinja 2 formats, and I run this Python script, and it renders those templates out and builds that directory. So in your case, I would say, I would use my mothership tool, and I would be like, okay, launch me an Azure cluster. And by calling my command line, it would go render those things. Because in Jinja 2, we can say, If provider is Azure, do this. If provider's that, do that. You can loop and do all that. So, good question.
When you get the mothership on GitHub, drop us a line.
Mothership on GitHub, I'll do it. Would you rather have that in Go or Python? Python, all right.
I call mine prefect, like a Roman prefect.
Nice.
Same mothership principle. How do you separate environments like production and like a pre-production environment as far as like templates? Do you have different directories, or do you have, say you have very similar, you want identical or very almost identical setup, but maybe you want a smaller VM in pre-prod to save on pricing or something?
Gotcha, okay. Lot to that. We're gonna, hopefully this is gonna answer it. So we have a repo, because the company's ŷhat, and I'm the least mathematically, that's some math joke. I'm not a math person, I don't get it. So I just focus on the hat part. So we have a repo called Milliner. A milliner is a hat maker. So this is yuck, yuck, yuck. And what we have here, I have this TF directory. And when you look inside my TF directory, I have two folders. I have env, that's where all my environments live, and I have modules, and that's where the reusable pieces live. And so if we look at modules first, it's really lightweight. I have a base VPC, so every sandbox, we called AWS and upped our limits, so every development environment gets its own VPC. So there's zero chance of network chatter, there's zero chance of customer security, your information leaking across the network. And so what you'll see in there is I've defined a cluster. So we have our ScienceOps product, and we have the ScienceOps cluster. That's the master and two workers. And then I have a master and a worker. And if you look into those files, the way those are being reused is the cluster calls for a master and then instantiates two workers. So multifacets to your question. I wanted to talk about this first. What's cool about this, when you define a module, you can use that module n number of times inside any other module. So if we take a look at ScienceOps cluster, again, my convention, I go with main TF, and I should actually do less. And so what you see is you see all these variables that I've defined at the top. And so I was talking about inputs and outputs. Your inputs are just variables within this module. And then I have my outputs. I'm saying, hey, for this stuff I made. And then down here, this was what I wanted to drive home, is where you bring in two workers. So I'm just instantiating the same module twice. So that first layer of abstraction becomes very powerful. If you can drill these things down to like, this is exactly what I need, and then I can just stamp this out as many times as I need. What you'll notice here, though, is that the name of the module changes. That's a name I make up. So I say module, and then this is my reference variable for this module, and then source is what actually points to the content. Now the second part, and I guess the kind of meat of your question, is how are we keeping these environments separate? So that's the env folder, and there's a lot of stuff in here. This is where the templates live for the mothership stuff, and all of our sandboxes. And I do complete copies of things. So we use Ansible to provision everything. Ansible will talk to EC2 for us. So the EC2 to INI file tells Ansible how to talk. So what we're doing there, because Ansible has access, the VPC locks us down, but that doesn't do anything at the API layer. So in those EC2 INI files, the reason there's one in all of those, that's saying, hey, restrict yourself to the security groups that are defined within main.tf within any of those. And so what's cool, you're talking about this isolation. So if we go into the environments, I'll do this again. So you can see there's core, so that's all of our core infrastructure. We have hosted core, so if we have a hosted client, their stuff is derived from hosted core. We have a client called Piano, so they're hosted, so we have this hosted Piano. And not all of our, unfortunately, I just joined ŷhat about 65 days ago, so they're one of the first customers that we've gotten full on Terraform. But if we jump in, I have a sandbox right now where I was caching some TLS requests. So if we jump into sandbox cached TLS, I could run tf destroy. You get one warning that this is permanent. I can hit yes. Oh, again, don't hack at 2 o'clock in the morning. Let's do SB. or let's see, we got to do two things. Let's go into my sandbox. This is interesting. So if I do TF plan in here, my access keys are set to my AWS account, so this is going to show up that everything needs to be new. But it's really cool. We can run TF apply. We can launch this entire cluster. It'll have a domain name attached to it. It does all of that. But did that answer it, or did I go too far? Did you say, what time is it? And I went, the history of the watch. Microphone, sorry.
Sorry, that was my parking reminder. No, so I guess you have like some sort of definition for each environment then in each directory.
That's the yeah, that's where the templates come into play. So the templates define all that. I run and I actually use invoke. If there's any Python hackers in here, I will never again touch argsparse. Invoke is awesome. Pip install invoke. I'll actually show you guys what this looks like. So I have all this right now configured in invoke. So this is my invoke script. And so there's things it reaches in and parses some stuff out for me. And one of the things, this is really easy to do, so we can do create SB dev. I enforce the naming convention. It'll be like, nope, I'm not going to let you launch a sandbox because you didn't call it SB. Because again, when you do look in the UI, things get really confusing. So we do enforce that. So we do SB dev demo, and it tells you, hey, I'm going to create this from the science ops thing. So then there, it's rendered out all of those Jinja 2 templates. And we can go into SB dev demo, and we'll just, sorry. When you use modules, there's another command called tfget. These are local. This is really cool. That works kind of like Go. I could give you guys a module. I could publicly release a module on GitHub. You guys could use my module by referencing my GitHub URL. When you run tfget, it'll go to GitHub. It'll go download the module, keep that module cached locally on your disk, and let you use it. In this case, it just sim-linked these because all of this is on disk. So you run tfget, and it fetches all your modules and brings them in. And we can just fire off the apply. And I'll try to remember to turn this off when I leave. But yeah, so you can watch that run. Was that it? Anybody else? Oh.
You mentioned Ansible, and you mentioned for provisioning. So I assume what you mean is this tool, Terraform, puts your infrastructure in place, Ansible installs and configures the software?
That's correct.
Cool.
Yep. Provisioning probably was too broad, but yeah. Terraform for the infrastructure, Ansible for the configuration.
Probably a quick one. What happens if there's a state change that happens outside of Terraform? How's that reconciled?
Aha. Terraform, and then again, oh, this, by the way, this broke because we're on mine. So what it tried to do here, it tried to reference an instance profile that doesn't exist for my account. So activate, let's see, we want AWS. Let it run for ŷhat, and I'll pay them back. So that's funny that you say that. Tags, we have a lot of hand slapping at the last place I worked because of security groups and tags. People will show up in the UI and they'll look around. They're like, oh, I need to tag this thing. This belongs to this customer. And they'll go add a customer tag. And then I'll run Terraform plan and it'll be like, oh yeah, here's a change detected. Need to take that tag away. So that's what it'll do. It'll go refresh based. It treats AWS as the master, the source of truth. And so it will sync down, it'll pull all the state that it knows about, it'll go out and say, okay, tell me about this bucket, tell me about this instance. And in this case, it'll say, okay, here's this instance, and here's the tags that I have defined, and here's the tags that are showing up. Oh, I need to delete that tag because it's not defined. In security groups, you run into a real problem with that because people will be in a hurry, they'll pop in, put an IP in, and then as soon as we run Terraform apply again, it'll bork it.
Okay, so it'll actually go out, it'll run the CLI tools or whatever for that particular service. And if you have your state stored on S3, it'll come and go back out to S3 and update your state.
That's correct.
Cool.
Is that it? Well, I appreciate you all listening. Thank you very, very much for your patience. Thank you.
Thanks, everybody, for coming out. Next, we've got Andrew Pierce coming to give a talk on Happy.js, right? Gonna make you happy. See you guys next week.